All right, everybody. So today what we're actually going to cover is we're going to start talking about shields, and then we're going to actually start talking about GPS and the particular GPS unit that we're going to use over the course of the rest of the semester. But first, we just want to go over basically how you expand upon the Arduino using these shields. Right. So in general, you want to be able to interface things to the microcontroller, to the Arduino. And one of the nice things about the Arduino is you sort of have that standardized footprint, that, horseshoe shaped pin layout. And that's designed so that you can basically have a bunch of standardized boards that you just stack on top of each other. Those boards are called shields, and there's actually a whole bunch of commercial boards that shields that you can just buy that are designed, with a specific task, right? You can also use them to do prototyping before you design your own, component. And so the Megasat that you guys are going to work with in the spring is a shield that we designed here at LSU, but there's nothing stopping you guys from designing your own, assuming you have somebody who knows how to do PCB layout and can design the circuits. But one thing that's really nice, and one of the reasons we selected the Arduino as sort of the basis of the payload, is because you can just buy off-the-shelf shields that will have certain detectors and components built in. And that means you don't have to assemble it or solder it. You just have to figure out how to interface. Also, because of that, there is online resources by the manufacturer, by the community, right, that can also help you troubleshoot, just based on other people who've used it, and there's documentation. But because it's basically a finished design, you're not going to be able to easily modify it most of the time. Obviously, you can do stuff like soldering wires directly to pins and stuff like that. And some of the shields may have built-in customization options, but right, in general, it's a finished circuit board that you're adding to your design. So it's more using what they designed rather than modifying it. So in particular, we're going to be using this shield here. This is from built by a company called Adafruit. They are one of the manufacturers that builds a lot of Raspberry Pi and Arduino hobbyist, boards that you can use. So this is called the Ultimate GPS Logger Shield. It has an SD card on it, right? So you can actually log data to the SD card, and it has a GPS unit on it. That's why it's called the GPS Logger, and then Shield is fairly self-explanatory. This particular footprint is based on an Arduino Uno, but because Arduino has the standardized across their boards, you can use it with other boards like the Mega. But some of like the pin labels that you'll see referred to are based on what those pins would be on an Uno instead of a Arduino. Something that will probably be useful to you guys in the spring is if you want to add a circuit to your payload, you can use something called a proto shield. So that's a shield used for prototyping, right? And they are basically blank boards that connect to the Arduino pins. but they're going to have a pattern of holes and pads on them for soldering components to. And they may be laid out similar to a breadboard. And the idea is that you can basically build your circuit on the proto board and solder it in. So that gives you a soldered finished board without having to design a PCB. Unfortunately, that has a limitation. You only have so much space, and having to lay out all the wiring on the board can get a little tricky and a little messy. But so this is, one example of what this would look like. There's several different versions of this type of thing. So you can see that it comes with the header pins. That's how you're going to connect to the Arduino. And this looks like that data logger. And then you use this space in here to build your circuit. And if you were to flip over the back side of this, you would see that some of these holes are actually connected to each other. Obviously, you probably don't want to just go straight to building a circuit and soldering it on here. You want to breadboard it and test it first, so you can make sure that it works before you actually build it, because it's a lot easier to move stuff around on a breadboard than it is components that are already soldered in. So one thing, if you do eventually learn how to do PCB layout, you can basically build your own shield, right? You just have to look up what the footprint is for the Arduino, and actually most of your PCB software will probably have a template, so you can just drop it in. But because you're actually laying that out on a circuit board, you can make things smaller. You can lay things out exactly how you want, and that lets you build, more complex designs. But obviously, that requires you to have somebody who knows how to use PCB design software, which for guys students at your level might be a little bit advanced. But especially if you're an electrical engineer, you will probably, before you graduate, learn how to use some of that software. And the other thing is that obviously you have to get those boards manufactured. That takes time and money. That's not as bad as it had been in the past. So it's a couple of weeks, and the prices have gone down. Yes, I have a question.
Yeah, what does PCB stand for? What is
So I was asked, what does PCB stand for? PCB is printed circuit board, right? That's just a circuit board. Basically, all of the circuit boards you guys have soldered to, right? It has the traces printed on it. So, and a footprint just means like the physical layout of the actual pins. So in that case, we're talking about those raised header pins that you plug into on the Arduino, right? If you look at these other shields, they're designed to fit into that. So it's just a standard shape so that everything can connect together. So this is a version of the Megasat. So that's what you're going to be building in the spring. So you can see that it has this same standard interface, right? You've got the U of the header pins. In this case, they're not all installed because in this version, there was nothing else other than the GPS shield, so they just didn't bother to install. But you could easily have and probably should have had the header pins installed here. So this is a board that was designed actually by Josh, who you may recall from the earlier lectures in this semester. And the idea is this gives you guys, a base set of sensors for your payloads, so that you can then either just implement that or add on to it to get a more advanced payload. And then you can see here that the actual GPS shield fits right on top, right? Because again, because it has that standardized interface, you just plug everything in together. So something that is somewhat similar, but not really the same thing as shield, is what's called a breakout board, right? So they are basically little small boards that have components pre-soldered onto it, right? They are not, what makes them not a shield is they don't have that standard, 3 sets of pins. They don't stack on. And the whole point of this is that it allows you to connect to smaller or more complicated components. So stuff that you probably wouldn't be able to solder on your own, but you will buy them a version with it soldered onto a board and then pins that you can connect to. So obviously you have to wire them up correctly. You have to connect to it properly. And then you also have to figure out a way to fit those into, what you're trying to design in your payload. In fact, one of the things on the Megasat is a breakout board. So you can see that this red thing right here is actually a separate board. And what that is it's the accelerometer and gyroscope, or the inertial measurement unit that you guys are going to use. So the actual IMU, or accelerometer and gyroscope, is this little tiny chip there. And that thing is very small, and also the pins are underneath it, so there's no way you would be able to solder that by hand. But what this has is it basically comes like this. So all of the components are on there, and you just have to connect to these much larger pins on the side, right? So this is what's called a breakout board, because it breaks out these little tiny pins to a bigger set of pins. And that allows you to interface this with this device. So like I said, there are many shields that you can just buy that do a specific function. Adafruit, that we already talked about, as a manufacturer. SparkFun is another big one. Also, there's just several that are on Amazon. One thing you have to keep in mind if you're using multiple of these shields, right? You're stacking them vertically, and they're using certain pins, right? But there's nothing separating all of those pins. Well, the same pin, right? So if multiple pins are going to use pin number 10, right, you'll probably have an issue, because all of those pin 10s are going to be connected vertically through the stack. So you need to make sure that they are, you don't have a conflict, or you have a way to get around that conflict. Also, there are differences between the multiple Arduino boards. Some of them use 3.3 and some use 5 volts. Most of the shields are designed so that you can operate them at both, but you always want to check, right? And then also, the different boards have different capability on different pins. So you may not necessarily be able to use one shield with different microcontrollers, right? So that's it. This was a pretty brief lecture that's just covering like how these shields work.